Right, just a wee bit more reminder about electron flow and resistance. If you remember that metals are made up of this idea of a lattice of positive ions and all the electrons which are moving randomly through the wire, but whenever you put a current or put it into a circuit, then the electrons flow from negative to positive. So electricity in wires is a flow of electrons along the wire. As the electrons move along the wire, they collide with the metal atoms. So it's this movement of the metal atoms. They're vibrating about their position, and the electrons collide with them, and that's what causes resistance in a wire. These collisions make the atoms vibrate more, which makes the metal hotter and causes resistance. So if you have too much current in your circuit, all your wires in your circuit are going to get too hot, and that it might cause them to melt, but it will certainly increase the resistance in the circuit and hamper the current flow. What affects the resistance of a wire? You don't have to do a calculation, although there is an experiment and an equation which you can get and which you would have used in your investigation. You just need to know the effects of changing things about the wire. So number one is the length of the wire. And you can see here on the right, a long wire and a short wire. So the longer the wire, you can imagine that it's that much more difficult for the electrons to get through a longer wire. If you can imagine yourself running a 1 kilometre race and a 10k race, it's going to be just that much more difficult for you to run a 10k race. So the longer the wire, you've got more resistance. The second example here is the area or cross-sectional area of the wire. And this time you've got a big fat wire and a little thin wire. They're both the same length this time. But if you have a bigger area, it's going to be easier for electrons to pass from one end to the other. So therefore the resistance decreases. And again, if you can imagine yourself, somebody telling you to walk along that white line there, or even run along a white line compared to running along a big wide road, you'd find it much easier to run along a big wide road than something very small and narrow. Number 3 then is the type of material that you use. And all materials have a property associated with them called resistivity. And you, again, may not need to know this word, but it's a good idea to know the resistivities of certain materials, how big or small they are. It gives you an idea. So something like copper would have a very low resistivity. That means it's got loads and loads of free electrons which conduct current, and they provide very little resistance or resistivity to the flow of current. But something like plastic would have a huge resistivity. It's got very, very few free electrons and very, very little chance of allowing current to flow. In other words, it's got a huge resistance. So the 3 factors are length, area, and the type of material, and the property associated with that is called resistivity. And the resistivity of a material, no matter how much of it you have, is always the same. It's just like the density of something always stays the same. It's a property of the material. Okay, we're going to use V is equal to IR to do some resistance calculations. The first one here, if you have a filament bulb and it has a current of 20 amps running through it with a potential difference of 100 volts across it, what is the resistance of the bulb? So we're going to use V is equal to IR. We've got a current of 20 and we've got a potential difference of 100. So potential difference is just voltage. And if we use V is equal to IR, we're looking for R. So we have to rearrange the equation. So R is equal to V divided by I. And that's equal to 100 divided by 20. And 100 divided by 20 gives you an answer of 5. And we have to use a unit, 5 ohms. Okay, next one then. This is a diode calculation. A diode is a current of 5 amps running through it and a resistance of 5 ohms. What is the potential difference across the diode? So again, if you just use V is equal to I times R, I is 5, R is 5, and V is equal to 25 volts. And that's fairly straightforward.